So this last one's a little bit tricky because it has a hydrate on it. So just to make sure we all know what hydrates are, I remember back in when we did this before, some people were a little hazy. It means that there are 5 water molecules stuck to the molecule that is in question, which in this case is copper sulfate. So this is copper sulfate. What's the pentahydrate, right? So copper sulfate pentahydrate. But what we care about here is how many of each of them these are to start with. So we can just go copper, there's 1, so I'm just going to do the number. Sulfur, there's just 1. Oxygen, we have to be careful here because there's 5 oxygens here and 4 here, so there would be 9 oxygens here. And then 5 H2s means that I have 10 H's. Now I know that hydrogen is just 1 gram, so that's going to give me 10 grams of hydrogen in total. Oxygen is 16 grams per mole because we're assuming 1 mole. So oxygen, that's 9 times 16 is going to give me, let's use a calculator. 9 times 16 would give me 144 grams. And sulfur, I would look at my periodic table in the back of my book, or you could look up there, but it's kind of far away from me. Sulfur is 32.1. Oh yeah, we had that last time. 32.1 grams, so that's just going to be 32.1 grams. And copper's formula, again, I can look that one up. Yeah, your book doesn't really go through this one. I actually like the little table, atomic masses of the elements in your book on page 340. And it just gives you them in alphabetical order so you can cheat. So I could just look up copper here without knowing where it is on the table and look at its atomic mass, which is 63.5. I know you can't see that from here, but you can see that the table is set up element, symbol, atomic number, atomic mass. So I can just use 63.5 from there. And that's all it's going to be because there's only one of it. So my total here is going to be all these guys added up. So I've got 0.6, looks like in that column. 0 plus 4 is 9. And nothing traded over there. So there's 10, 4, so 249.6 grams is my total, which means that I'm going to make these other ones percentages out of that total. So we'll do that. 63.5 out of 249.6 will give me my percentage. Oh, but this just says what the percentage of water in it. So I needed to get all of these. I don't actually have to figure this out for this question because they just want the water. So what I'm going to have to do then is I've done this to figure out what my total is, but for my water, I just need this part here. So I'm going to need, 10 for H2O. I'm going to need 10 H2s, so that's 10 grams of hydrogen, and 5 oxygens. Not the 9 that was in the total, but just 5 oxygens. So 5 times 16, and that's going to give me 5 times 1, 80 grams. So I add these guys up, and that's 90 grams of water for every 249.6 grams so of the total solution. So I'm going to do that instead. And that turns into 90 divided by 249.6 gives me 36.1%. So, percent. So this was a little bit cheekier of a question because they didn't just want all of the percents. They wanted you to find the total, which you're going to have to do every time because percents are out of a total. So we find the total mass, the molar mass of the compound. And then you find the mass of the specific thing they're looking for. So in this case, they wanted water. And then you make that as a percentage over the total, and that gives you your final percent composition.